recognized. Told you a little bit off here. This is our observed. We had a total of 35 students in this class. We gave you percentages up here. So what we actually then have for our expected values is we're going to use this percent, 0.153 times 35, and we get 5.355, meaning we ended up with 7 kids getting a 5. We should have had about 5.355. We had 22 kids here, 22% here. That comes out to be 7.7 students. Here's 8.68 students, 6.93, and 6.355. And again, I got these 18.1% times 35. And yeah, we are going to use some rounding here. That's okay. We can round. When we did the M&M activity, we could have rounded as well. But I chose not to make the answers a little bit easier. So these values here will go into L1. These values here will go into L2. Again, observed go into L1. Expected go into L2. Now, I've done that already. And I want to show you how we do this on the calculator. And then we'll go through the 4-step inference toolbox. Now, I have these on my calculator. L1, again, score of 5, score of 4, score of 3, score of 2, score of 1. Expected values, score of 5. Expected values, expected, expected, expected. To get this, again, I did L1 minus L2, the quantity squared, divided by L2. And that's what L3 was. We did that all the way up at the top. I then went through, and I added that up. I ended up with this, 7.59. That's my chi-squared test statistic. But here's what's important. Without the work, it's worthless. So, I want to quickly go through this. Step 1, population would be students taking the AP Stat test in 1997. That was given in the problem. And the parameter are the students correctly distributed in the distance learning lab, in the distance learning class. Those are kids who take it over a computer. In the distance learning class. Are the students correctly distributed in the distance learning class? We would also say here, ho, they are correctly distributed, and ha is they are not correctly distributed. So there's step 1. Step 2, SRS. We have to double check to make sure all our expected values are greater than or equal to 5. These are our expected values, and we were close, but we're good enough. So that is a good. So check yes. And we're going to do a chi-squared goodness of fit test. Step 3, chi-squared. Here's my formula from the bottom of page 5. Observed minus expected, the quantity squared over expected. And we just said that was 7.59. I had 5 possible scores. My degree of freedom is 4. And using my AP packet, degree of freedom of 4. Again, the first value is 5.39. Going across, I see 7.59 is between 6.74 and 7.78. So my p-value is between 0.15 and 0.10. When we compare that to alpha, p is greater than alpha at the 0.05 level, we will fail to reject ho or accept ho. What that means is, what we can basically say here now is, since we have, sorry about that, since P is between 0.10 and 0.15, P is greater than alpha at the O5 level, and we accept HO. What does this mean? This means the scores are correctly distributed for the distance learning class. So, we've done 3 problems now. I went through this last problem kind of quickly. We went through, actually 4 problems. The M&M, Trix, Skittles, and the AP problem. All 4 of them are fair game. What I'm going to show you here in a moment is the chi-squared goodness of fit. What I want you to do now is clean up this one we just worked on, 13.1, and I want you to turn it in, pass in the papers to your right, and pass them up front over there to Casey.